PIN code. It must be a 4-digit code. He must use exactly 4 digits from 1 to 9. No digit may be used more than once. Work out how many such codes are possible. What do you reckon? 9? 9 choices for your first number. When you choose one of the digits, how many choices do you have left? And when you choose one of them? And when you choose one of them? 324. Now, would you be so nice as to try this method out as well? What happens? It's permutations, isn't it? Which means a code of 1, 2, 3, 4 is different than a code of 4, 3, 2, 1. Would you agree there are two different codes? So I could have used 9, pick 4. Try that on your calculator. 9, pick 4. So go 9, shift, pick 4. 3024? Oh, same answer either way, yeah? Okay. Work out how many of these digits contain the number 2. 2 is already chosen. Agreed? I think what happens if we just do 2 is already chosen, yeah? So that means 8 of them are left over. I chose 2 as one of the numbers. Oh, 2 could be in 4 different positions, right? Grant. I'll take that into consideration in a second. So 8, pick 3. And then, so 1, 8, 3. Huh? 336. Okay. Now, what is 336 multiplied by, for argument's sake, 4? That is the correct answer. Now, I need to explain to you guys how we got that, all right? So we still remember there's the 4 slots, don't we? And 2 could go anywhere in these slots, agreed? So 2 could go here, it could go in this one, it could go in this one, or it could go in this one. That's 4 different ways 2 could be allocated in there. The other 3 numbers can be picked using 8p3. And what do you guys say 8p3 was again? 336. And we multiply 336 by 4. 1,344. Do you want to see another method of doing the same question? Okay. It should be a yes, because sometimes you need to be able to think about these things differently. Now, here's what I'm thinking. Okay. Imagine I decide to place the number 2 in the first position. How many choices do I have? No, I placed the number 2 in the first position. Has to be the number 2. So that's one choice, right? Given I chose the number 2 already, how many choices are left? And after that, 6. But please remember that number 2 can occupy any of these 4 positions. So I do 4 by 8 by 7 by. And is that the same answer? Is it? Okay. Happy days. You all good? They're tricky, aren't they? They seem very all or nothing. You get all the marks or not enough of them. Okay. Now, work out how many of the codes in B part 1 have the sum of their first 3 digits equal to the 4th digit. Whoa. These codes can contain the digit 2, although they do not have to. All right, let me give you a good example of this, all right? Here's a classic example of this. 1, 2, 3 equals. So the code is 1 plus 2 plus 3 equals 6. That's a legitimate code. We start small. Let's start with 1, 2. What's next? 1, 2. And that's 7. 1, 2, 5. And that is 8. 1, 2, 6. 9. Let's keep going then. Yeah, that's it. They can all be jumbled. Sorry, shh. The 4th digit can't be jumbled around. Would you agree with that? The fourth digit can't be jumbled around. But this one would work the same as 2136. You see what we're saying? Just give me a second. I'm still actually figuring it out currently. I haven't practiced this one before, so yeah, just give me a second. What I'm trying to do is I'm trying to assemble the first three. I'm trying to assemble the first three numbers first, and once I do that, then I'll figure out what I'm doing after that. You could also use 1, 3, and 4, couldn't I? What do I get there? 8, 1, 3, 5, 9. Okay. I can't use 136. No. So and I've done all the 1 2s, haven't I? What about 1 4? 1 4? Can you use 1 4 1? Can you use the same digit twice? 1 4 2, and that gives me. And then 1 4 3. Sorry. I've already done one. I've already done 1 2 4. So sorry, I'm repeating my work at the moment. What I meant to start off with was I meant to start second with 4. So not 4. Try 2. 2. I've never led with 2, have I? 2 2 3. 2 3 4. Have I done 2 3 4? 2 3 4 is not represented up here, is it? No. Okay. And what's that then? 9. All right. How many of them is there then? 7, is there? 1 2 3 4 5 6 7. Okay. Now the deal is that you guys told me earlier. See these three here? They can be arranged in any order you want, can't they? That could be written as each one of these can be written in 6 different ways. I'll show you now. 1 2 6 1 6 2 2 1 6 2 6 1 6 1 2 6 2 1. Basically, there's 3 by 2 by 1. 3 factorial ways of doing that. So I have to multiply 7 by 6 and get an answer of 42.